Coronal mass ejections, or CMEs, are huge clouds of plasma and magnetic field occasionally thrown off by the sun. Scientists study them because the massive bursts pose a threat to space-based technology and even power grids on the ground. Within each CME lies a kernel known as a flux rope, tightly wound groups of magnetic field lines that can contain and transport solar material. Astronomers have seen them as the CME bursts off the sun, but they have been next to impossible to detect on the sun itself. New research using NASA's Solar Dynamics Observatory has now shown that they can be seen in just one of its cameras, which shows the very hottest material on the sun. By watching a flux rope form and eject as a CME, the research has brought some closure to one long-standing mystery: whether ropes form before or during the CME's eruption. It's impossible to actually see the flux ropes, or any of the sun's powerful magnetic fields involved with CMEs and flares, because these fields are invisible. But scientists can map them by observing plasma trapped by these fields, which shows up as thin lines in extreme ultraviolet light. Since Earth's atmosphere naturally filters this UV light, scientists must observe it using telescopes in space, such as NASA's SDO. This wavelength is usually reserved for studying solar flares, but what NASA and Naval Research Laboratory scientists found is that the flux ropes associated with CMEs could only be seen at this temperature. On July 19, 2012, a CME erupted from the visible edge, or limb, of the sun. Because it was on the limb, the flux ropes were in profile and particularly visible. Even more important, the flux ropes appeared about 7 hours earlier in the same location. The ropes were visible as a line of figure eights that looked exactly the way theorists predicted they would. This is the first direct evidence that flux ropes form well before a coronal mass ejection. Footage of the CME from the SOHO spacecraft confirmed the presence of the flux ropes. By adding footage from the Stereo A spacecraft, which is viewing the sun from an entirely different angle, the researchers were able to create a three-dimensional picture of the flux ropes. For the most part, they follow the classic figure-eight pattern previously observed and predicted by solar models. But some of these ropes also had feet which extended farther away than scientists expected. This deviation from the models is interesting and requires further study. Besides showing proof of early flux rope formation, this study also paves the way for future flux rope and CME research by literally finding a new light to observe them in. The possibility of using flux rope formation as an early warning system for CMEs means that this line of research can have some very practical and far-reaching applications. And it can also help wrap up some of the long-standing mysteries of the sun.